Yeah, good morning, and thanks for the opportunity. I will present our work about the evaluation of visual and non-visual effects of electrochromic glazing in the context of one Brazilian city.
It's not working.
Which one? Thank you. Thank you. This has been published in Journal of Daylight, so if you want to have more details, it's a new publication, and is also part of a PhD study. Some of the assumptions of this work is that the intense use of glazed facades is very large, also in Brazil. The glass box buildings are very common. And of course, the dominant economic formula is to have a compact building and the solution of glazing facades. If this is a problem for cold countries, you can imagine in sunny and hot climates the consequences of this. We have problems related with glare, overheating, and this is one reason to study new materials, innovative materials for the facades. In the modern architecture, we had a lot of clear glass used, normally with shading protection. From the 80s, intense use of reflective and also translucent facades, but nowadays we have, especially in non-residential buildings, this trend of glazing facades. So you can see many cities in Brazil with the same solution, and this is also for new buildings and both retrofits. This is a case in Brasilia that one building from the 60s was totally renovated with totally glazed facades. So this is another example. And so this facade, this kind of facade with uniform and cluttered appearance from the exterior have a high market valuation, as we already discussed it here. And there is a few influence of environmental quality and energy efficiency impacts in these options. So, of course, we know already, we have heard about this from Mandana and other speakers. The presence of the windows is very important. We need to have daylight outside views, and also recently we have this new criteria to have the supply of non-visual effects and circadian light. So the electrochromic glazing could be a solution to balance the circadian lighting and avoid glare. And we are trying to understand how does it work in this kind of climate. So we have normally we have a variation light transmission from 60% to 1% from clear state to dark state. And this has been studied in many countries, in many kinds of climates, but it's not so common to have both studies about visual and non-visual effects. We have a research center in Sangoban in Brazil that they have electrochromic glazing in facades, but it's not still commercialized in our country. So the aim of this study is to investigate electrochromic glazing for daylighting conditions, including visual and non-visual effects. The method includes simulation in Brazilian climatic context. We are using Climate Studio for visual effects like daylight autonomy, useful daylight illuminance, daylight glare probability, and alpha for non-visual effects. So the simulations were this is the first city where we have done the simulations, and in a representative non-residential office space in Brazil. This was defined based on other research. It's not a very big room, and we used a smart glass insulated unit technology with a layer with electrochromic coating as a glazing system that is available on the market. We have optical properties in international glazing databases. So it was, and the simulated variables were the orientation, the glazing material. We compared electrochromic glazing with clear glass, and also the time. Of course, we must simulate. We have dynamic simulations for the visual effects, but for non-visual effects, we had to simulate solstices, equinox for each orientation from a period from 8 a.m. to 6 p.m. And this is the room and the optical properties. I won't be very detailed here. We have an analysis grid with 9 points. And here we evaluate the illuminance in horizontal plane and both in vertical also. And for visual effects, we have these 3 metrics that are very well known: spatial daylight autonomy, useful daylight illuminance, and daylight glare probability. For non-visual effects, we evaluated melanopic equivalent daylight illuminance and the melanopic daylight efficacy ratio that is more related with the spectrum of the light, the fidelity of the spectrum. So the shading schedule is a first result. We can see that there is a strong necessity of shading in the north facade in many months. This is due to the direction of the sun. And if we compare clear glass with electrochromic glazing regarding the visual effects, we can see that electrochromic glazing is very good. We had no problems to achieve this first metric. Also for useful daylight illuminance, it was also a good result. There was an improvement in this metric in all cases for electrochromic glazing. About glare, it's also very clear that the mitigation of glare is provided by the electrochromic glazing, especially near the window. We evaluated by the zone of the room. And about non-visual effects, we evaluated first the circadian light. So we could see that it depends on the position of the room and the window orientation. Not, for example, is not favorable. So in general, electrochromic glazing performs better, but there is a gap in this for this orientation in this specific glazing. And about the melanopic daylight efficacy ratio, here we really found a problem because clear glazing performing much better than electrochromic glazing regarding this spectrum. Just to summarize the results, we can see that for visual effects, electrochromic glazing performance is good. It performed better, maintaining the illuminance levels on horizontal grid and also vertical grid. The mitigation of the glare was achieved. So the shading schedule generated by the electrochromic glazing avoided this direct sun, prevented problems. Of course, there is a problem in north facade because excessive shading. But we begin to have problems with a lower supply of circadian light for the north orientation. So we have some disadvantage here in this point. It's a point that should be reflected about, and definitely a lower melanopic daylight efficacy ratio. And we can conclude that regarding the spectrum, the lower melanopic daylight effect is observed for electrochromic glazing. So we have probably we have distortions of the spectral distribution of daylight. So electrochromic glazing, we can say that generally it has a higher balance between visual and non-visual effects, especially for visual effects, glare control, and circadian light. And the next steps of this research will be to simulate in other situations of sky conditions and latitude to see what are the results and to put it together, to have a better evaluation of this product, this component for Brazilian conditions. A hot climate condition, I would say, a very sunny climate. That's all. Thank you very much.